of Paper 1 Leave the Start Maths. This video is going to be covering factorization. Alright, so factorizing is basically you want to split something or a function or some x's and y's up into such a form, mainly because you want to solve it equal to 0, and then it becomes very, very obvious as to what the solutions become. So that's why you're doing factorization. It's not just, you're not doing it for any old reason. It's so if you want to know when your expression equals 0, you need the factors of it, because then you can just read off the solution straight away. So that's why factorizing is very, very powerful. So, so when you're doing factorization, what does that mean? There's a few things to know. One of them that is stupidly important, okay, is the difference of two squares. They love, over at the examination board, they just love this. So a squared minus b squared can be factorized into a plus b multiplied by a minus b. Okay, now just as a sanity check, that is true, but you might sit there and say, how is that ever true? So in the last video we did multiplying out brackets, so I'm going to do this, multiply by this, multiply by this, and then I'm going to do this, multiply by this, and this, multiply by this. So what I get is a by a is a squared, a by b is just ab, so it's just minus ab, b by a is plus ab, and b by minus b is minus b squared. These two terms here cancel, so I'm just left with a squared minus b squared. And therefore, you can just say that a squared minus b squared can be written as a plus b, a minus b. So do learn this off. For your leaving cert, it's almost guaranteed to come up. And it's one thing if you're asked to factorize something and you see two things and there's a minus in between them, you should probably, it's probably going to be difference of two squares. Okay, so instantly, personally, whenever I see a minus and two things and I'm asked to factorize it, I'm just like, okay, probably minus b form. Sorry. Difference of two squares. So that's basically what your, it should just be the second you see it, you instantly think difference two squares. Now, maybe a difference two squares? No, doesn't have to be, but it's one of those things that it definitely should run through your mind the second you see two terms. So something like this. So it could be something like 49 x squared minus 225 y squared. This is a difference of two squares. So this is equal to a squared minus b squared. Now, and then this is going to be equal to a plus b and a minus b. Now the problem is, what do a and b equal? Now, a foolproof way of doing this is just taking the square root. So we know that a squared is going to be equal to 49 x squared, and b squared is going to be 225 y squared. Okay, from this expression up here. Okay, so from this one here. So from that, we get this, and that means that a is just the square root of this, which is 7x, and b is going to be the square root of this, which is 15y. So just plug it into your calculator, the square root of 49, 7, the square root of 225, 15, and then the square root of x squared is x, and the square root of y squared is y. So that means that we get 49 x squared minus 225 y squared is equal to 7x plus 15y multiplied by 7x minus 15y. So that is that factorized. All right. Now there's other types of factorizations. Now this you would have covered in Leaving Cert. Junior Cert. Now the problem is that tons of people have different ways of doing it. So I'm going to do it my own way. If so, there's two options. Either you can already factorize quadratics. So for something like this, so factorize this. So again, there's two options. Either you already can factorize and therefore you can skip this video, but if you're watching this, I'm assuming stuff like this is still troublesome. So I'm going to show you how I personally like to do these, okay? So what you do is you split this number and this number into its factors. So what are the factors of 3? Just 1 and 3. What are the factors of 20? 1 and 20, 2 and 10, 4 and 5. Okay. Now, another thing that's important is that when you're looking at the factors of a number, what you do is you say, okay, does 1 go into it? Yes, obviously. 1 goes into 20, so the other one is... So 1 multiplied by what gives me 20? 20, you know? Does 2 go into 20? Yes. How many times does it go in? 10 times. So it's 2 times 10. Does 3 go into it? No. Does 4 go into it? Yes, it goes in 5 times. Now, why didn't I... Now, just think about this. Why didn't I test for 6? So why isn't there a possibility that 6 goes into 20? Like, what? So why did I stop at 4 multiplied by 5? And why did I know to stop at 4 multiplied by 5? What you do is, the one you just checked, so 5 goes into 20. 5 squared is 25, which is bigger than 20, and therefore you don't need to go past 5. Okay? If I wanted to find the factors of 3, again, why didn't I check? I know this is a stupid question, but why didn't I check why 4 isn't a factor? The reason is because I didn't need to check 3, and I also I did need to check 2 just in case. Obviously 2 does not go into 3, but 2 squared is 4, which is bigger than 3, and therefore I can stop at 2. All right. If I wanted to do say 48, well, 7 squared is 49. So because 7 squared is bigger than 48, the only numbers I have to check for do they go into 48 is 1, 2, 3, 4, 5, 6, and 7. And if you do that, you're guaranteed to get all the factors. You won't miss one. Okay, so that's the method as to how you do these. Now, the reason I did the factors on the left-hand side is basically now I know that it's going to be 3 and 1 that I'm going to use. See, on the right-hand side, we've multiple factors. On the left-hand side, we only have 2. And therefore, I can just use 3 and 1. So that's fine. So what you do is you draw a big X like this, and you draw, you write 3x and 1x. These two things are interchangeable. It does not matter if the 3x is on the top or on the bottom. I just put the 3x on the top. Now, notice, if I multiply these two things together, I get that. And that it also has to be true for these two things. So when I multiply these two things, I need to get minus 20, specifically. Okay? So now, what you think about, you say, okay, so my left thing is perfect. I have 3x multiplied by 1x is 3x squared. Perfect. Now, on the right hand side, I have tons of choices. I can do 1 and 20, I can do 20 and 1. I can do 4 and 5, I can do 5 and 4. I can do 2 and 10 and 10 and 2. Now, the question is which one is correct? So, another thing, there's a minus here. I'm going to highlight it and then get rid of the highlight. So there's a minus there. What does that mean? That means one of these things are positive and one of these things are negative. So one of these things on the right hand side. So this number here and this number here, one needs to be positive and then one needs to be negative. Why? Because let's say they were both positive, then positive by positive is positive, and therefore I can't get the minus in front of the 20. Because again, I'm multiplying these two things together, okay? If I did minus by minus, I get plus again, so it can't be that error. So that tells me that one is positive and one is negative. Okay? So, now that we have this, now I need to choose. So I'm going to get rid of these, but, for the time being, what you do is you test and you see, okay, after a while you get better at these. But, let's say I have no idea. Let's just assume minus 1 goes there and plus 20 goes down here. Could be completely wrong, but let's just assume it for a second. You do 3x, multiply by 20, that's why these arrows are here. So you're multiplying that number by that number, and this number by this number. So, I can do 20 multiplied by 3x is 60x. 1x multiplied by minus 1 is minus 1x. 60x minus x is 59x. And see here, we have 11x. So whatever when you add those two things, you need to get 11x. Here we get 59, so it's not minus 1 and 20. Again, if I did 20 and then 1, I also get something that's way too big. Okay, so it's not these two. Now let's try 4 and 5. So now I can try, say, 4 and 5. Again, I want plus 11. So I'm going to let the 5 be plus and the 4 be negative. So the reason is because if I do 3x multiplied by 5, I get 15. X multiplied by minus 4 is minus 4x. So I get 15x minus 4x. And that is indeed 11x. So this is correct. And then your factors. Your factors then, you go from left and right. So this thing factorized is 3x minus 4 x plus 5. That's how you get them. Okay. So hopefully that makes sense. So the reason we have to go from left to right is, I'll just do it quickly. The 3x is multiplied by the x. That's where the 3x squared comes from. The 3x is multiplied by the plus 5, which it is. The minus 4 is multiplied by the plus 5. And the minus 4 is also multiplied by the x. Okay? So that's basically where those come from. Okay? So that's that factorized. Now, I'll just do another one just to kind of hit home. So we have 8x squared minus 18x plus 9. Again, the factors of 8, 1 and 8. If I plug in 2, I get 2 and 4. I plug in 3, 3 doesn't go into 8. And remember, 3 squared is 9. So basically, because 9 is bigger than 8, I can stop at 3. Alright? Same thing for 9. 1 goes into it. 2 doesn't, 3 does. And I can stop at 3 because, again, 3 squared is 9. And therefore, I don't have to check to see if 4 or 5 go into it. I can stop at 3. Now, again, that's just giving you a tip. That you don't have to. You don't have to do. Check 4, 5, 6. It's just to save yourself time. That's all I'm doing this for. It. You don't have to learn this off or anything. It's just in the interest of time. It's just better. So again, I'm gonna put my x and x here, and put my lines here. Now, this one is slightly different. Here we have a plus. So first of all, we looked at the minus case. Now we're looking at the plus case. So the plus case basically means that both of these signs on the right hand side are either going to be both positive or both negative. And in this case, they're both negative. Why? Because that's negative. And therefore, both these must be minus. Okay? So that's how you do these. So you say, okay, Are they both plus or both minus? Grand. Because this is plus, so the plus in yellow, because that's plus, they're either both positive or both negative. The minus 18 in the middle gives you, is a minus, and therefore those two signs must be minus. Okay, so now your job is to try and think of, okay, how do we get 18 out of these? Okay, so you can try 1 and 8 if you like, but just in the interest of time I won't, because it's wrong. So the 1 and 8 just won't work, basically. You can probably imagine this, because if I do 1 and 8, if I multiply that by 1 and 9, I get 1 and 1 is 1. 8 times 9 is 72. That's way too big for 18. And then if I do 8 times 1, I get 8. 1 times 9 is 9. Add them together, I get 17. So close, but it's not 18. And that's why I can... And then the 1 and 8 times 3 and 3 can also be disregarded. So this is going to be 4 and 2. And again, the 1 and 9 here can't be used, because regardless as to where I put it, 9 multiplied by 2 is already 18, and basically what you get is just too big. So you only way here is for 3 and 3. Okay, and we'll check. 4x times minus 3 is minus 12x. 2x times minus 3 is minus 6x. Minus 12x minus 6x is minus 18x. 4x times 2x is 8x squared. So remember, if you multiply these two things together, you need to get this. If you multiply these two things together, you need to get this. And then if you multiply it across using your x's, you need to add together to get minus 18. So this thing is, again, reading from left to right, we get 4x minus 3 multiplied by 2x minus 3. So that's how you factorize those. Now, these ones you just need to learn off. They're a sum and difference of two cubes. So if you get a cubed plus b cubed, this is equal to a plus b. A squared minus ab plus b squared, and then a cubed minus b cubed is going to be a minus b into a squared plus ab plus b squared. So these two things just need to be learnt off. If you'd like, you can multiply these out, and you will find that they are a cubed plus b cubed and a cubed minus b cubed respectively. But yeah, I'm not going to. So that's just a definition of the algebra. Okay, so now you could be asked to factorize something like x cubed plus 125. This is obviously of the form a cubed plus b cubed, where a equals x and b equals 5. So if I plug x into the equation, I get x cubed, which is x cubed, and then if I plug 5 in for b, I get 5 cubed. 5 times 5 times 5, so 5 times 5 is 25. 25 times 5 is 125. So this is what it is. And then I'm just going to plug that into the equation up here. So we get that x cubed plus 125 is equal to x plus 5 into x squared minus 5x plus 25. And that's it. Okay. And then just to do one difference, we can do 64 p cubed minus 27 q cubed. This is going to be equal to a cubed minus b cubed. Here, a is going to be 4p and b is going to be 3q. Because again, if I do 4p cubed, I get 4 cubed, which is 64, p cubed, which is p cubed, perfect, and then b 3 cubed is 3 by 3 by 3, which is 3 by 3 is 9, and then 9 times 3 is 27, and then q cubed is just the 27, and then just plug that back up into this formula up here. We get the 64p cubed minus 27q cubed is going to be equal to 4p minus 3q into 16p squared plus. Just be careful with your pluses and minuses here. I almost got caught there. Plus a multiplied by b, which is 12 pq plus 9q squared. Okay. So that is how you would do something like that. All right. Now I'll do one more example on this sort of stuff, because it can get tricky if they start to, throw things in on top of you. I'll do these a little bit faster, a little bit less explaining, but it's it's just the same thing. So if we get 9px squared plus 24px minus 9p, you always have to remember, first thing of factorizing, what is common to, because now what's happening is they're basically throwing things on top of you, and you're having to react and realize what you've been given. There's a p here, there's a p here, there's a p here. So there's p's that are common, all right? Also, 3 goes into 9, 3 goes into 24, and 3 goes into 9. So I can take out, or you can say that 3p is common, and therefore I can take it out. So if I take it out, 9p divided by 3p is 3, so I just get 3x squared. 24 divided by 3 is 8. Px divided by p is just x. 3 minus 9p divided by 3p is just minus 3. Okay. And now I want to factorize this. This factorized is going to be 3x squared plus 8x minus 3. Again, the factors of minus 3 is just 1 and 3. And the factors of 3 are just 1 and 3. So this is going to be 3x and x. Again, this is minus, which means one of these is plus and one of these are minus. Now we don't know yet, but we do know that they have opposite sign. You can pick 1 and 3. So let's just say 1 and 3. Okay, just guessing. We need to get plus 8. So let's say this is plus and this is minus. X times 1 is x. 3x times minus 3 is minus 9x. Minus 9x plus x is minus 8x. This is plus 8x, not minus. And therefore I got my signs wrong when I chose back here. So let's try it the opposite way. Let's try minus and plus. Now we get minus x plus 9x, which is plus 8x. So this thing here is equal to 3x minus 1 and x plus 3. And therefore our whole expression can be 3p, 3x minus 1, x plus 3. And that's the final answer for that one, okay? So it's the second they start throwing stuff in on top of you, it can get a little bit nasty. Another one, we can do something like sorry, I'm just looking for something like this, yeah. So this, if we get like 3x cubed minus 648. Now, the same way that if you have two things and both are squared, you just instantly think difference of two squares, here you think difference of two cubes. So just as a reminder, a cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. Okay, so that's just to remember that. And so now here, what are we going to do first? Well, is anything common in this expression? So there's a 3 there. Does 3 go into this? And the answer is yes. So first of all, I can take out a 3. Okay. So you always just have to keep your wits about you when it comes to these and just say, okay, well, is there anything common? Can I, is there anything that I can take out first to make my life a little bit easier? And in this case, there is. So you get this. Now you can use your formula. Why? Because this is just x cubed and this is 6 cubed. So now I can plug it into my formula and say this is equal to 3. Now my formula up top is going to be x minus 6, x squared plus 6x plus 36. In this case, just in brackets, that's an over bracket. Just in brackets, we get that a equals x and b equals 6. Okay? Alright, so that concludes that. Now, the next thing is to do is how do you add fractions? Alright, so adding fractions is like once you just understand that it's like currency, it's like units, you can't add a fraction to another fraction unless you have the same things. You're comparing like for like. So if I asked you just in your head, what's a half plus a third? You look at me funny and you say, I have no idea what that means. Because it doesn't, no, of course it makes sense. Of course it makes mathematical sense, and it wouldn't take long for you to figure it out. But at the end of the day, it is quite difficult to conceptualize that. But if I asked you what's 3/6 plus 2/6, you'd say, oh, well, 3 plus 2 is 5, so 5/6. That's the answer. All I did was I changed a half to 3/6, because 3 divided by 6 is a half, 1/2. And 2/6 is a third. So I just gave you from previous videos, if you watch them, it's the lowest common multiple of 3 and 2 is 6. I changed it to 6, and all of a sudden it was very easy, So that's all you're doing here. When you want to add a fraction, you want the bottom number to be the same so you can add like for like. Okay, that's all. So for example, might do a new section. So for example, we could have x minus 1 over 5 plus 2x minus 4 over 3. Okay, actually, hold on. Sorry, just to make this a bit harder, and so I can kind of do two things, and when I can explain two concepts in the one, I'm just going to change that to a minus. So now with the minus, what we have is I want the bottom number to be the same. I want to minus them off each other. So again, adding and minusing are basically the same thing. So again, if you want to add fractions or minus fractions, I just want the bottom number to be the same. Okay. What is the lowest common multiple of 5 and 3? The answer is 15. 5 multiplied by 3 is 15. So the lowest common multiple of 5 and 3 is 15. Now, this always works when you just multiply them together. 5 times 3 is 15. Just be careful. We did it in a previous video, but basically you just split a number into its prime factors, and then you only have to deal with what isn't common to both. So 5 isn't common to 3, and 3 isn't common to 5, and therefore I just have to multiply them. I can't simplify it any further. Whereas if I asked you what the lowest common multiple of 4 and 2 is? The answer is 4. Because 2 is common to both 4 and 2, I can do 4 multiplied by 2 is 8, and then 8 divided by 2. Why am I dividing by 2? Because 2 is common to both. So yeah. But in this case, we're using 15. So you just put it now over a big fraction of 15. Now, question. How do I go from 5 to 15? I multiply by 3. Now, when you're adding fractions, you need them to stay the same size. So what's happened is I've multiplied the bottom by 3. The only way I can do that is if I also multiply the top by 3. Why? Because if I multiply and divide by 3, I'm multiplying by 1. I'm not doing anything. 1 multiplied by 3 is 3. 3 divided by 3 is 1. So I start with 1 and I end with 1. So I haven't changed the value. Because if I asked you what a half plus a quarter was, and then you went off and told me that it was 27, I'd be telling you, oh, well, you were after, you can't just multiply things or divide things willy-nilly, So here we need to preserve the value. And therefore, if I multiply the bottom by 3, which is the same thing as dividing the whole thing by 3, I need to multiply the top by 3 as well. So I'm multiplying 5 by 3, and therefore I need to multiply x minus 1 by 3. Okay? Now, how do I go from 3 to 15? I multiply by 5. Now, be careful. It's minus 5 multiplied by 2x minus 4. Why? Because back up here, this is the reason I changed to a minus, just so I could do 2 birds with 1 stone. That minus says you minus the entire thing. And that's why the minus is here, because I'm minusing the whole thing. Okay? That's why the minus goes outside. So you can think of it back up here, that it's minus all of this. Okay? If you'd like to put brackets, you can. So we get this. This now, multiplying out, is equal to 3x minus 3 minus 10x plus 20, all divided by 15. And this is just going to be minus 7x plus 17 all over 15. And that's the final answer. Okay? Now, we can also have, you want to add fractions like this. Where now you have linear terms down in the bottom. Okay. Now just think for a second what you would do and how am I going to add these two things together. Now, hopefully a couple of you will, see this and have an idea as to what you're going to do. But if you don't, just think. Is there any reason I would change my approach from the top to the bottom? Is there any reason I'd have to change, or is there any reason as to why that maths wouldn't work? The answer is no. That this is kind of a conceptual hurdle that you'll need to get over. And then maths becomes much, much simpler. If you just look at it and you say, listen, people get scared with these x's. They just see, they're like, oh, it's an x, oh, what do I do? You need to remember that the x's are just numbers. So they act like numbers. And therefore, if they were numbers, like up here, like 5 and 3, you say, oh, you multiply them together, and that was it. You're going to do the exact same thing here. So I'm just going to multiply them together, quite literally. And that's now the number on the bottom. So up here, we did 5 multiplied by 3. Here, we're doing the 3x plus 5 multiplied by 2x minus 1. Okay. Now, how do I go from 3x plus 5 to 3x plus 5 multiplied by 2x minus 1? I multiply by 2x minus 1. So it's 2x minus 1 multiplied by 1 plus 3 multiplied by, how do I go from 2x minus 1 to 2x minus 1 multiplied by 3x plus 5? I multiply by 3x plus 5. Okay? Now there's no need to multiply this out. Please do not. Just leave it the way it is because something might simplify. So just make sure not to multiply that out because there's no mark scoring for it, so there's no need to do it. But also, if something does simplify, you mightn't catch it, you know. So here, this is 2x minus 1 plus 9x plus 15 all over that fraction. I just can't be bothered to write it. So 9x plus 2x is 11x plus 14 all divided by 3x plus 5 and 2x minus 1. So that's that. Now, can anything from the bottom divide into the fraction on the top? No. If we happen to get 3x plus 5 on the top and 3x plus 5 down the bottom, then I would cancel them out or divide them out and get 1 over 2x minus 1, but I don't. So nothing can be gotten rid of from here. Okay, last one that I'll do, this is a tricky one, but it has very nice properties. Now, again, is there anything in common with the numbers below the line at all? So is there anything common between this number and this number? Just think about it. The answer is yes. They are actually the exact same number. Okay, that's why I chose this one. So this number here is actually just equal to minus 1 multiplied by x squared plus 3x minus 18. So all you have is a minus 1. And then this is the same as that. So what does that mean? That means I can rewrite this as 3x all over x squared plus 3x minus 18 minus, I can bring the minus up, so I get minus 18 all over x squared plus 3x minus 18. And this is equal to x squared plus 3x minus 18, 3x, minus by minus is plus, so it's plus 18. Alright, now, are we finished? I'm actually not too sure. No, we're not. So, another thing is that above here I asked, okay, does anything from the top divide into the bottom? And the answer was no. Now, here I actually don't know. Okay, no, I do know. But I'm assuming everyone who's looking at this screen can't tell if it does or it doesn't. So I need to change x squared plus 3x minus 18 into its factors. So its factors are x and x. 18 is going to be 1 and 18. 2 and 9. 3 and 6. And those are the only ones that are there. So now, this is minus, which means one of these is plus and one of these is minus. Now, see, there's 1x and 1x. They're the same thing, and therefore it doesn't matter where I put the plus or the minus because it's just x and x, you know? They're just the same thing. So I need to get a plus 3. How do I get a plus 3? By using 3 and 6. If I use 6 here and 3 here, I get 6x minus 3x, which is 3x. So this thing is equal to x plus 6, x minus 3. So I can plug that back in. So if I plug it back in, so 3x plus 18, 3 is common to that. So take that out. Down the bottom, you get x plus 6 multiplied by x plus 3. These divide out to give 1 and 1. 3 times 1 is 3. 1 times x plus 3 is x plus 3. And so that's the answer. So that is the full simplified version of that. So always keep your wits about you. Just when you're factorizing, just say, have I factorized everything? Just be careful, because it's very, very easy to just get caught up, you know. Now, okay. Yeah, I might leave it there. This video is already long enough. Yep, thanks very much for listening. I'll go over factorization 2 in the next video. And yeah, we'll go from there. So yeah, thanks so much.